First, the workflow. NFX streamlines the repetitive design, eliminating the tedious, time-consuming process, leading to an optimal work process. Now, this model contains numerous small fillets and holes. The fact that they do not influence the analysis, we need to simplify the model. As you can see here, we can use a dedicated simplifying function to search, check, and delete small features within a defined dimension. In the case of an assembly model, we need to define the relative motion between the parts. That means defining the contact condition. We can simply select the entire parts and select a contact type to define the contacts for the entire model. NFX then compiles and registers all the contacts under the workstream for us to check and revise the contact types without ever having to touch the model. When it comes to defining the loads and boundaries, we select the target faces and simply use the context menu. Whether you're an expert or novice, you need not worry about generating the finite element mesh for your model. Midas NFX does it all for you. NFX examines various geometric characteristics in your model and automatically generates the optimum mesh. More often than not, we face difficulties in analyzing a vast amount of results. Depending on the type of analysis, we ask ourselves what menus to use to check what critical items for design. No more worries now, thanks to Midas NFX. NFX compiles and registers the results required for design checks under the results workstream. You just need to double-click the relevant check items, be it displacements, forces, stresses, or safety factors. In addition to the standard check items, you can also add specific check items to suit your design purpose. I will now move on to explain the CAD file update feature. When an expert creates a template defining the standard simulation conditions, the designer can follow the procedure to carry out the analysis. The designer is able to obtain credible results and evaluate and improve the design. The designer does not have to have extensive knowledge in the use of NFX or even the related analysis theories. Another big advantage of NFX is that such template-based design analysis can easily counter when there are changes in your design staff members. Now, I'll be addressing how contacts are defined in NFX. I will now explain the process of carrying out linear static analysis, reflecting the sliding motion between parts through this example. First, simply select all the geometry parts. We then use the functionality of auto contact definition to define the contacts between the parts. The defined contact conditions assigned to specific parts can be checked, and if needed, we can modify the conditions. Next, we use the context menu to define loads and boundaries and carry out analysis. If the model has not been meshed, the program automatically generates optimum mesh. The next feature is geometry cleanup. Whenever you want to create a desirable analysis model, you often need to simplify your model. This particular model has many small fillets and holes. We know that such small features are analytically not so important, but create too many unnecessary elements or poor mesh. This, of course, reduces the accuracy or the efficiency in analysis. You can prevent this by using the simplifying functionality in NFX. You can remove the unnecessary features automatically or manually, ending up with optimum geometry for efficient analysis. I will now talk about the superb capabilities in mesh generation as the last subject. NFX provides three main features in mesh generation. The first is hybrid meshing, which generates hexadominant mesh. The second option is that when you define no mesh control, the program automatically recognizes the geometric characteristics and generates high-quality mesh with an optimum mesh density. Well, what can be better than this? And finally, the program provides parallel meshing based on multi-cores. We can use this functionality to generate mesh for a significantly large assembly model very fast. The model you're seeing is an assembly of 113 parts from which hybrid mesh is being generated. Finally, we have created hence a dominant mesh of 640,000 elements under 1 minute.